Okay, today is the first of 4 videos under the topic of solving trig equations, and we'll have some different titles, but today's part 1 is about simple trig equations. Simple. First of all, when we begin, I want to make sure that you understand that each time we'll be solving over the interval from 0 to 2 pi. Note the hard bracket on 0 and the soft bracket on 2 pi. You want all the answers in this particular equation that fall within one circle of the unit circle, one rotation of the unit circle. You will not count 2 pi, you will count 0. I will not repeat this instruction over and over, but it is the same instruction each time. Now, first of all, let's talk about what we mean by simple. Look at this particular equation. Tan x minus 1 is equal to 0. A simple equation implies that there is only one trig function mentioned. It's not sines and cosines, it's not tangents and cotangents, it's just one function. So this is all about tangents, and that's all we're going to deal with. And each of these simple functions that we talk about will only, simple equations will only deal with one function. So if this is our variable, we're going to solve this like we always do. We're going to isolate the variable. We're going to bring 1 to the other side. And at this point, you're ready to start thinking about your 9-part chart. And you're asking yourself, where is tangent equal to 1? What angles? And the answer that you would give yourself is that we need pi over 4 angles. I sometimes in class will draw this in a little cloud. Pi over 4 angles in quadrant 1, where everything's positive, and also in quadrant 3, where tangent is positive. So our answer then, x is actually the angle pi over 4 in the first, and in the third it would be 5 pi over 4. There are 2 answers to this problem. If x is pi over 4, then its tangent is 1, and if x is 5 pi over 4, its answer is also 1. If you're wondering what tools you need to work with this, you need to know your 9-part chart, you need to know what quadrants things are positive in, and you need to know your quadrantal angles. All right, that's all for that one. Let's look at the second one. The second one brings to the table a squared function, 4 cosine square x equals 3. And the first thing you would do if you were solving this particular function is you would divide both sides by 4. So you would get this. Cosine square x equals 3/4. Then you want to take the square root of both sides, giving you cosine x is equal to. And remember, when you do that, you get a plus or minus. Take the square root of 3, it is the square root of 3. Take the square root of 4, it is 2. So basically, we want to know where cosine x is equal to plus or minus square root of 3 over 2. Now, in the 9-part chart, I'm going to draw just a portion of it here. We're going to focus on the cosine row, which is the second row. And we're going to remember that the square root of 3 over 2 lives right there under pi over 6. So basically, here's my little thinking cloud. I want pi over 6 angles. I want the 2 that are positive, which would be quadrant 1 and 4. But I also want the 2 that are negative, which would be 2 and 3. So basically, whenever we have one of these squared functions, we end up with all 4 quadrants. So the cosine is square root of 3 over 2 for all pi over 6 angles. And so our answer, x, would equal pi over 6 in the first, 5 pi over 6 in the second, 7 pi over 6 in the third, and 11 pi over 6 in the fourth. So generally, whenever you have this plus or minus situation, you're going to have all 4. Now, if you're sitting here watching this and you're wondering where I got those angles, remember I just go 1/6 away from each of the horizontals. So this is 0, this is 6 pi over 6, and this is 12 pi over 6. And so basically you've got 6 minus 1, 6 plus 1, 12 minus 1. 4 angles for that one. My last example under simple is this problem. This is also a single function problem, so just cosecant. If we multiply both sides by 2, we get the cosecant of x is equal to 2. The problem is we do not deal with 2 on our 9-part chart. So we're going to make another statement. We're going to change this problem. Therefore, if the cosecant of x is 2, then the sine of x is equal to 1/2. And if you will allow me just a minute, we'll just draw a simple part of the 9-part chart. Let's focus on the first row. That is the sine row. And there's the 1/2, and that is also under pi over 6. So the x value will be, here's my thinking, I need the pi over 6 angles. I need them in the 2 places where sine is positive, which would be quadrant 1 and quadrant 2. So my x values would be pi over 6 in the first and 5 pi over 6 in the second. The 3 points of these problems then, we have a simple problem that was just straightforward. The squared problem, let me bring that back, squared problem, remember you need to take plus or minus the square root. You should get 4 answers. And then the simple problem that involves one of the lesser important functions, cotangent, cosecant, or secant. You can simply write that function again in terms of sine, cosine, or tangent. These are the simple equations that you've had to go by. I wish you luck with this, and our next video, which will follow this one, is about quadratic functions. That's all for now. I'll see you next time.